Hello everybody, I am the Draft Doctor, and today I'm going to show you how to lay out the Y branch, also known as the pair of pants. We're going to use triangulation, and what we have here is 7-inch round, large diameter, branching off at 260 degrees angles and picking up a 5-inch round on each end. Now, as you can see, both these are symmetrical, therefore I only have to lay out one half of the pattern, duplicate it, and I've got the whole thing. This is the simplest of the Y branches and the first in the series that I'm going to show you. This fitting has a 10-inch center line, and what I've done is gone ahead and lay out part of the working drawing, most of the working drawing actually, and just to save a little time, I've laid out my 7-inch round. I've constructed using my triangle 60 degrees, measured 10 inches. I can use my same triangle to come perpendicular, put a line perpendicular, measure a 2.5-inch radius, and then scribe my profiles for each of my branches. That's basically where I'm at right now. Once I've located these two edges on my working drawing, I can now connect back to my 7-inch round to complete this side of my working drawing. And since the fitting is symmetrical, we go with 1.5 times 1.5 times large radius, and that will give me my sector height. So if I go 1.5 times 3.5, which is the radius for my 7 round, I end up with 5.25 inches. I measure up this high, and that completes my working drawing. Now, it's pretty much got me caught up to where I'm at. My next step is to use the radius of my profile to divide this profile itself into equal spacings for my layout. This shows where they're going to land on the round, and when I bring them down at 60 degrees to my working drawing, it will show where they all land on the 5-inch round itself, giving me points from which I can triangulate from. Now I don't have to copy this on both sides because this fitting is symmetrical. So what happens on the one side is basically going to happen on the other side when we trace. So I found these 6 element lines, 7 if you include the 2 commons here. 7 points, 6 spaces on my 5-inch round. Now to make a match of that, I need to now put a profile that's going to represent my 7-inch round at the bottom of this drawing. So using a radius of 3.5, I can now swing an arc that represents my 7 round, and I'm also going to divide this circle up into equal spacings as well. And there we have it. I can show how those element lines are represented on my elevation view by projecting them from my profile to the base of the fitting, and that's going to show where they all land. Next, I need to divide this sector up into equal spaces as well, and we're just going to imagine it was a half a round, which it is almost a half a round other than the fact it's elliptical. It is 7 inches deep by design because we have 7-inch round here, but if our sector is 1.5 times the radius, then its diameter would be the large or major axes in an ellipse. So I'm going to take that major axis and I'm going to represent it and I'm going to represent it in a quadrant or a quarter of the circumference. I'm also going to take this major axis, and using that same radius, I'll divide that axis into equal portions, and I will now reflect them back to the sector to show where they locate on my sector. These are where the element lines are going to be represented in the elevation view, and we found that by using the major axes. Now, how far are these points away from each other? We don't really know until we develop the ellipse that they are represented in. So I'm going to take these spacings and just stretch them up. And now what I've done is located a profile of this actual quarter ellipse, and it'll have a point right here, it'll have a point right here, a point here, and a point right here. So this now is what we're going to call our sector profile, and it will look almost, well, very close to this, other than my freehanding abilities. Now I have a quarter profile that represents this part of the diameter, which is half the diameter. I have a half a profile that represents this diameter, and I have an elliptical profile that represents my sector, which we know to be elliptical. We're ready to number this fitting. The first thing I want to do is I'm just going to extend this diameter right here both ways, because I plan on using this as a true length triangle. I'm going to lay this fitting out in order. So I'm going to number it in the same order that I'm going to lay it out. In other words, 1, 2, the next point I find would be 3, and then I will find point 4, and likewise. So that makes this 6, 8, 10, 12, and 14, and likewise at the bottom I have 1, 3, 5.7 here, and I have 9, 11, and 13. So now I've numbered my points all the way around. When we're triangulating, we are going to have to triangulate the elevation lengths over the difference of the falls. Now, what does that mean? If I look at my profile view, I can see that 2 and 14, as well as 13, pardon me, and 1 are all on the quarters. In other words, 1 and 2 would be rendered now a true length. However, 2 to 3 would not be a true length off of here, simply because 2 is on the center and 3 is this far from the center. That means I have to take the line 2 to 3 and triangulate it over the difference of the falls. 2 is on center, which would be my baseline, and the fall of 3 is here. We're going to repeat it many times so you'll get it. We're ready to lay out a pattern. And I'm going to start right about here. I guess that should pretty much do it. My seam will end up here, which will be the last points I go. So if this is symmetrical, I'm going to build it out both ways. What I do on the left hand side, I'm also going to do on the right, and we'll pull it up later to show you how that works. The first thing that I have to notice is that 1 and 2, if they're both on the center line, then they are definitely a true length. So here's point 1, there's point 2. Oh, lucky me. And we have to document point 1, point 2. From point 1 got this backwards, sorry kids, 1 and 2. From point 2, point 4 will be 1/12, or the 1/12 spacing that would be required for the 5-inch round, which is this distance right here. From 1 to 3 on the bottom end of this fitting is determined by the 1/12 spacing for the 7-inch round. So point 3 in that regard will be somewhere on this circle. Point 4 somewhere on that circle. I found 1, I found 2, my next point will be point 3. I'm going to take from point 2 to point 3 off my plan view right here. I'm going to swing it down to my baseline, and knowing that it has to be triangulated over the full fall, since 2 is on center and 3 is that far off, this now becomes the true length of line 23. So from 2 I find point 3, 3, 3. From 3 I have to find 4. Well, point 2 to 4 is already represented by the 1/12 spacing, so now I'm going to take the elevation view of 34 and drag it down, and I have to triangulate over the difference of the falls. Point 4 is falling this much from center. Point 3 is falling this much from center. I need to now triangulate over the difference of those, which puts the true length of this fitting, puts the true length of this fitting at this point right here. Now from 3 I find 4. From 3 I get point 4. Back to my 1/12 spacing, which is right here. From 4, 6 will be on that arc. From 4, 6 will be, somewhere on this arc. 3 to 5 is part of the 7-inch 1/12 spacing, so we're just going to pick it up from here. And point 5 will be somewhere on this arc, and likewise somewhere on this arc. And we're going to repeat the process. I have 3 and 4. I want to use 4 to find 5. Well, first thing I need to do is take the fall of 4. I want to subtract it from 5. Now I'm going to take my line 4, 5 off of my elevation. There's 45. Pull that down. There's 45. The true length of 45 is now going to be the difference of over the difference of the fall. So slightly longer, and there we have it. From 4 I find 5. From 4 I get 5. From 5 I want to find 6. I have my relationship of 4 to 6. Here is my 56 length. I'm going to drag that down. 56 is this one. I have the fall of 6, and I have to subtract that fall from 5 and triangulate over the difference. there now is my 56 length. So from 5, I now find 6. From 5, I find 6. Back to our 1/12 spacings. I see 7 is still on the 7-inch round. So we're going to come back to the start here and pick up this radius again. Somewhere on this arc will be 0.7. And on this side the same. And now we're going to take our 1/12 spacing for our 5-inch round. Pick it up from here again. 0.8 will be on that arc. 0.8 will be on that arc. And we're just going to zoom out now a little bit. There we go. Five, 6, I need to find 7. Using 6, I'm going to take the fall of 6 once again, subtract it from 7 now. I'm going to take the length of 67 right here, bring it down to my baseline where I'm triangulating, and triangulate once again over the difference of the falls, which is right there. And now from 6, I find 0.7. From 6, I find 0.7. One of the benefits of the numbering system I'm using here is that if I forget where the heck I am, all I got to do is look and count. 5, 6, 7. Oh, I'm looking for 8. I'm now going to take 8. I'm going to subtract the fall of 8 from the fall of 7. I'm going to take the true length, or not the true length, but the elevation view length of 78 now, and we'll pull that down, and I'll just mark it big so I can see it, and I need to triangulate over the difference of 78, which is that distance right there. From 7, I find 8. From 0.7, I get 0.8. 8. And I can see I've got a nice consistent curve happening here. That's a good indication that my layout is accurate. From 8 to 0.10 is going to be the 5-inch 1/12 spacing once again. From 8 to 10 is there. From 8 to 10 is there. Next, 7 to 9. Oh, look at 9 is now part of our ellipse. From 7 to 9, I have to get off of my quarter ellipse pattern, which is that length right there. From 7 to 9, and now it's going to start heading up because I've come around a corner here, so I'm going to swing that arc kind of high. 9, somewhere on that arc. I'm going to use 8 to find 9, so I need to subtract the fall of 8 from the fall of 9. Here's the fall of 9. I got that laid out when I laid out my ellipse. There's the fall of 9. The difference of the falls, that tiny little bit right there. So now I'm going to take 89, and instead of going down this time, I'm going to bring it up to here, which gives me another true length triangle that I can measure from. So plan length or elevation length of 89 is here. The actual true length of 89 is right here. And from 8 now, I get 9. From 8, I get 9. I want to find 10 with 9 now, so I'm going to take the fall of 10. I'm going to subtract it from 9. I'm going to take the elevation length of 9, 10 right here, swing it up to my true length triangle, triangulate over the difference of those falls, which was the long one here now, right here. And now I have the true length of 9 to 10. And once again, maintaining a nice consistent curve on that top 5-inch round is an indicator that my layout is happening in the regard that I want it to. There's 10. There's 10. Point 11 from 9, point 11 is this far. Once again, I'm taking it off the arc. And we're now laying out the sector. 11 will be somewhere on that arc. 11 will be somewhere on that arc. I need to subtract 10 from 11. 10 from 11. And just because it comes on the other side doesn't mean a darn thing. All I need to do is extend this line. We are triangulating over the difference of the falls. It doesn't matter what side of the line the difference goes to. So, back to here, 10, 9, 10. I'm looking for 11, and I'm using 10 to find it. So, 10, 11. There is my 10, 11 length. I'm going to drive that up to the true length triangle. 10, 11. True length of 10, 11. Right there. From 10, I get 11. From 10, I get 11. In order to find 12, I have to come back to my 1/12 spacing on my pattern. There's my 1/12 spacing for my 5-inch round. Point 12 will be on that arc somewhere. Point 12 will be on that arc somewhere. From 11 to 13, I'm going to get it off of my ellipse or my sector profile, is that length. And from 11, 13 will be on that arc somewhere. From 11, 13 will be on that arc somewhere. I need to find 12 from 11. Let's start by taking the fall of 12 once again. There's the fall of 12. I have to subtract it from 11. From 11 to 12, I have an elevation view length right here. Bring that up to my true length triangle. Triangulate over the difference of the falls, which means taking it to that length right here now. Let's straighten these out. True length of 11 to 12. Once again, I'm seeing that nice even flow across that top stretch out. From 12 to 13, 13's on center. 12 has a fall of that much. I'm going to create me another triangle now. Let's take this baseline right here now and just extend that a bit. You'll see why right away. If I'm using 12 to find 13, 13 is on center, 12 has a fall of this much, so I'm going to take this elevation length and I'm just going to swing it up to the base of 12 now that I just put in. And now the true length will be over the full fall of 12 right there. And now from 12, I get 0.13. Oops, it moved on me. I get 0.13 from 12. I get 13. 13 and 13. From 12 to 14, back to our 1/12 spacing on the 5-inch diameter, which was right here. Somewhere on this arc will be point 14. And likewise, somewhere on this arc will be point 14. Now, since 14 is on the center and so is 13, that makes 13 to 14 a true length. So from 13, I now find 14. From 13, I now find point 14. We found all our points. 13 to 14 is my seam. 14 to 13 is my seam. From 13 down to 11 is (13, 11, 9, 7) is my sector. Likewise over here I have 7, 9, 11, 13, and it will look something like that. At the base here I have half of my 7-inch round. Slip. And at the top I have my 5-inch round. So I have 5-inch round. I have 1/2 of 7-inch round. I have my sector and my sector. If I want to form this now, here's what I want to do, or attempt to do. From 8 to 7 I'm going to mark it. I'm going to mark it from 8 to 7 here as well. Now that I've broken that up, you can see that this has to roll 90 degrees. On this side of the line, I have to roll 180 degrees. And on this side of the line, 90 degrees. Now this is all going to relate to the 5-inch round. The other side here, we can, if we set our rolls up properly with a slightly bigger radius at this end, it will take its shape quite reasonably. One thing that you should notice, if you are putting a lap and spot seam on here, you don't have to mirror the fitting, just simply trace it, because when you put the insides together, the other seam will come to this side, completing your Y branch. This is the basic Y branch. I hope you've enjoyed. I am the Draft Doctor. Hit the like button, subscribe, and most of all, have a great day.